Good morning.
Hi, good morning, sir.
Yeah.
How are you?
I'm really good. Glad to be here.
Great.
Um, I'm very excited because we're getting ready to start really building stuff at Softmax, and it's
Okay.
it's a very exciting time to be you start working on a project which is more open-ended, and you never know when you're going to find something it's worth like going to actually do. So it's exciting.
Okay, thanks. I mean, we are one of the largest lab in Germany, and which is established through the German government. The aim of the center is to develop, on one hand, let's say, future software stack for the future, for the next generations of vehicle,
Hmm.
and other hand, to try to improve the acceptance through the society. That means two major expectations. One is inspire the industry where they are staying, on that how they can use AI, how they can increase their AI competency. The second hand, how we can increase the acceptance through the society. I mean, we are working on the different domains. One is one of the domain where we are working very intensively, where we believe we are one of the leading uh, lab in Europe, and it is autonomous vehicle. And the second area where we are working on is which we call is future of the work. That means in the future world where we have a digitalized environment, how we can increase the productivity of our society, of our employees,
Right.
and that is another issue where we are working.
Yeah. I probably should say what Softmax does. So I'm Emmett. I started Twitch before, so I was in video games and esports, and then I was briefly CEO of OpenAI, which is a real wake-up call about the state of AI. And I decided I needed to get involved, and so I wound up starting Softmax. And Softmax is an alignment research company. So we're researching this question of, say you have a bunch of agents of some kind, human agents, AI agents, cats, and you wanted them all to be aligned. You wanted them to have some sense of shared goals that stayed coherent between the agents. What would it mean to do that? Could you do that? Is it possible to create a stable attractor? Is it possible to do that? And so that's sort of the open research question we've been working on.
I mean, from my point of view, AI, OpenAI did really huge. I mean, their effort, they spend a lot of effort. They created excellent result. When AI had the current state, they contributed to them, a lot of them. It is effort of the result of the, let's say, OpenAI. The question is what will the next behind the OpenAI, where we will go. And I think, from my point of view, the next big thing where we will work on, it will be what we call super agent. That means system which we were able to connect to the different models and and develop plan and execute them and reflect to their interaction and to their result observation and use them. That means learn that, use them for the future. That will be, that means what we are expecting, system like a human.
Yeah, I think the current trajectory is towards these models that are ever better at continual learning.
Exactly.
What you're talking about is this process where you have these models that are capable of continuing to observe the results of their own actions and learn from that and keep rolling. I think that it's going to require a pretty significant change to how people train models, though, because the issue with continual learning is you start off with some loss function that tells you
Exactly.
some reward that tells you what to go do, and in the beginning that's good, but then as you keep going, you start to just, if you're a person, you start to notice, oh, well, like, I know I had this rule about how to just, but like, really good is more like this thing. And so somehow we learn not just a predictive model that like converges against a loss function. You then go backwards and use the model to learn a new loss function.
Exactly.
And we diverge again. And it's the opposite of, everyone's always trying to get their model to converge. And, well, I think actually we need to learn how to make the models diverge. It's sort of that's the missing piece. And so I don't know that the current trajectory of steering and like control steering, like that's all more about keeping it in the lane rather than letting it diverge.
Exactly. I mean, let's say continual learning, or we call them real-time learning. It will be one of the next big challenges. And for them, as you mentioned, we have a lot of face a lot of challenges, really to learn, to develop a technology which allowed us to learn in real-time manner where they can contribute to the quality of the result.
Yeah.
I mean, from the real-time learning or continuous learning, our expectation is to have a system which is better than the let's say, previous version. And that will be, in terms of the autonomous vehicle, autonomous driving, your vehicle has to learn. That means you have to be able to, in the real-time manner, to label them, label them, and to generate new model and train your ongoing system with the model.
We have a pretty good solution for real-time learning as long as you only want about 2 million time steps. If you only want 2 million time steps, the context window, transformers, it certainly does real-time in-context learning, like shockingly well. The problem is like, if you only want to drive your car for like, whatever, like 2 million ticks per, I don't think it probably gets you to the store. I think it probably gets you like 3 minutes down the block at most. And so I think there's sort of two ways to think about the problem from my point of view.
Yeah.
Either it's about how do you solve the memory problem for transformers where you can have a sliding window and then you can somehow compact the learnings, or you have to figure out how to make training real time. And I think they're probably equivalent in some sense. Like there's probably some law that shows that they're dual. I don't know. We don't really understand machine learning yet, but someone's going to have a law that shows that those are the same thing.
I mean, another big challenge is, let's say, challenge is if you have a system which is on running, and that means you have to train them in the operation, and that is one of the largest challenges, to make sure that we are doing no mistake, and in terms of the autonomous driving, that meaning of them is not causing.
I mean, I think a lot about how I invested in training product managers at Twitch, which was that like, I realized at some point that my product managers weren't growing. And I realized it was because every time they were about to launch a bad product, I told them why it wasn't a good idea and why it was not going to work, and then we didn't launch it. And then they didn't get the learning experience that got me to be good, which is the contrastive loss against this is what it looks like when it doesn't work. And when I stopped saving them, our product management got a lot better because they had this opportunity to learn. And I think the same thing is true for the models. The idea that you want to prevent the model from making mistakes, well, like, not if you want it to be robust to, you want it to be able to keep learning. That's good. If you know exactly the right thing to do at all the points, by all means, just like supervise, learn that. But like, otherwise, you need the model to like be able to try things that don't work and learn from the not working.
Exactly. And from another challenge will be in the future, that explainability. That means system can explain the human. We are expecting from the system the explainability, how the result came, and that system have to be able to explain that. That is another challenge. And in order to increase the acceptance through the society is not interested to see only the result.
Yeah.
How the result can.
Yeah. What was your reasoning for this? Why did you come up with this thing? What's the motivation in this coming to existence? And there always, for one of these systems that's kind of a goal-directed system, there always is a motivation. But right now, the existing models have a very weak I would say they have a self-model, but it's a very weak self-model. They don't have they certainly don't have a sophisticated, multi-scale self-model that can understand, their own learning. They don't understand their own learning dynamics. They don't understand how their decisions influence their learning dynamics. And that's the kind of stuff you have to actually understand if you want to be able to give a real accounting of like, I did this because, well, there's actually like a lot of weights. I did this because there were these like 7,000 tokens at these activations. It's true, but it's not very useful. And we need it to learn a coarse graining, learn a coarse grained model of its own behaviors. The tricky part then is it starts to have its own opinions about what it's supposed to be doing. It's like stops being so much of a tool and starts being more of a being. I think we really have to grapple with that.
But as I mentioned, that is one of the major roadblocks, and what we have to work on them, and if you are solving them, then we expect that the future, let's say from the future AI, much more acceptance through the apply the AI, or let's say deep tech, in the different domains such as health, such as more autonomous driving and future of work and energy, all of the critical infrastructure where we are expecting from the system that has to explain us.
I think there's actually quite a bit of a trade-off between how predictable the tool is and how self-reflective it is.
I mean,
self-reflective tools are sort of intrinsically unpredictable.
I mean, when we started the trial in Berlin with the autonomous bus, we have one of the largest bus, 12-meter passenger bus. We got approval for them operate on the road. The first passenger which were on board with them, they was really very, very scared, and so most of them, we started the trial. We observed them. Whole bus is fully digitalized, that's inside and outside. Inside with a lot of displays and then cameras, and where we were interested in to collect the information about the behavior of the passenger. What we found out, it was the first step where we have them. The second, after we found out that most of them scared, we enhanced them functionality to additional functionality, really very easy explainability, and where we explain them how the bus, the behavior of the bus. And we found out that was really that improves the behavior of the passengers, and that is easy way, but the issue what I mentioned is explainability will be very important for
so this is, I
society.
didn't quite understand. So you had the instrumentation on the bus, and then you got the bus's own behavior.
Exactly, the bus.
And then you had that explained, the passengers learn the bus behavior.
Exactly, the bus is able to explain to you your behavior. That means we are, this thing what we did in Germany, we in Berlin, we had a 23-kilometer digitalized road, where we are collecting the information from the road.
I'm asking, I think, a much dumber question. Like, what did you actually learn about the buses? Like, what was it, like how fast they're going, or like what they were?
Exactly. They can explain you how they are stopping, how they are why they are driving slowly than as allowed.
So it would tell the passengers it's slowing down because of this.
Because of the next traffic lamp, which jump to the red, or or kids on the road.
And then the passengers are much less like antsy about it. It's like in the elevator. If you don't show people what floor the elevator's on, they go crazy because it feels like they're just waiting forever. But if they can see where the elevator is, that makes sense.
One hand, the bus is explaining them. The second, that's showing some facts. Showing them traffic lamp, jumping from the yellow to the red.
Yeah.
So, okay, it's me. Or they're showing the kids is on the road.
Yeah.
And
Well,
other animals are.
And now it
under
makes
the-
sense. Now
Yeah.
the bus is slowing down. It's not frustrating. It's normal.
Yeah.
Yeah. It
Now
reminds-
everybody loves
yeah,
the
yeah.
bus.
In fact, it's better than a human driver because I tell you what's
Yeah,
going
yeah,
on.
exactly.
I think what's interesting there is that all of the normal mech interp stuff for mechanical interpretation stuff for LLMs is focused on trying to explain the weights and the weight activations, but like what you're talking about there is very much about in the moment what inferences are being made right then and there. And it makes one of my theories about this has been if you want to have that kind of explainability where you have some insight into like why is this happening right now, you actually have to train something about on the latent activations themselves. You have to train the in the moment activity to and it's just really hard because that's like changes so much. So it's a tricky problem, but like it seems like it's interesting to me that no one's done that. I actually have long felt that was like the place to go.
Exactly. As we started, we keep them explainability very easy, okay? And after that, the second thing, what we did, we integrated LLM. We collected all of the data, all of the perception information from the vehicle, and from the environment, let's say from the road, and to the LLM. And right now we are working the next generation of them explainability via LLM.
Cool.
That will be the new version.
So,
But the issue what I would like my remark was explainability will be very important for the acceptance. I mean, we had another trial where we worked with the Berlin Medical Center, or which called Charité, which one of the best medical university in Germany, and we developed a system for the pathologists.
yeah.
That means, as you know, the pathologists when they're getting sample, they're analyzing sample, and they think what they're doing. They are analyzing them. In the end, they say, okay, I statement what they found out.
Right.
The next thing what they have to do is predict what can be happen in the future. Not only what the current perception is, what will be in the current prediction. We did a large trial with them, and the result was the system are really excellent. It was huge consortia which worked on that system, and we developed some new AI methods for them, and after we enhanced them to the explainability, we found out that people, let's say, users such as doctors, medical employees, and patients, when it changed dramatically. Let's say their behavior.
Yeah.
They were much more relaxed. They were much more relaxed. Understood them.
Just think about a person. If you're hanging around a person and they're really unpredictable, their behavior is erratic, it's very stressful. You don't know what to expect next. And so by giving some insight into like the underlying causes, you smooth everything. Things become more predictable to you. You aren't being threatened by sudden surprise. It's very close to what we're doing at Softmax. What we've been working on are these little simulations, and you have lots of little agents in them. And we don't train LLMs. We're training little LSTM models that just traditional PPO reinforcement learning, like it's the 80s or something, or the 90s, I guess. But what we're training them on is in-context learning behaviors, and then where they have to do in-context learning behaviors where the other agent's behavior is important for theirs.
Exactly.
And what happens is, you notice when you start to train them in this setting, that the agents kind of try to make themselves more explainable. Their behavior becomes smoother because they need the other agent to be predictable. And so they become smooth. And the whole system goes from this sort of turbulent flow to a laminar flow of like, because the agents are now in an environment where it matters whether they're consistent or not. And I think that's and consistent with what? Well, consistent with what the other agents model them as having goals. Because it's not they're doing the same thing, it's that they're consistently acting in accordance with a legible series of goals. And the only way you can learn that is you have to learn in a social environment where you're around, well, either humans can do it for you, or if you want the AI to learn it, it has to learn in a social environment where it gets to get training data about how others perceive it so that it can learn to understand itself through their eyes.
I absolutely agree. In the future, we will have a better quality of the explainability. We will enhance them through the, let's say, learning through other agents.
Yes.
We will observe their behavior. We will collect the information and learn more, improve them, our explainability.
Well, we should, of course, we put a lot of effort into explaining other people's behavior, and we should put even more effort probably into explaining the AI's behavior. But I think that it's equally important that we help the AI not only explain itself, but act in a more explainable way. Like we kind of insist that people do this. If people are always acting in weird ways, we get kind of annoyed with them. And we need the AI to learn that it needs to behave legibly, or no one will be able to trust it.
Exactly.
Yeah. I think we're out of time.
I think as in our previous session, the gentlemen, they underline it is very important, deep tech, and utilize the deep tech with some AI. My opinion is they have to use the current state of the art of AI, but the future of AI will be something else.
It's going to be very different.
Exactly. It will be very different, but will be something else. But for Europe, for the world, we have spent a lot of effort to develop a system which can help our economy and which can help our society.
Yeah. I think that's I hope the motivation for everyone doing something at some level is they're doing something that they think is going to somehow help everybody, be part of the bigger thing.
Thank you very much.
Yeah. Thank you.